Integrating this function is what we are going to see. But please don't forget to subscribe to the channel. Now, these are very easy integrals to deal with. Why? Because when I'm going to handle this, you will handle this in your free time. Now, these are the integrals that you integrate when you have a function and its derivative. So see that this one, if I'm handling this specifically, I need to create a function up. I mean, I want to create the derivative up. But when I'm putting the derivative, I need to introduce in an exponent with a negative x. Now, if I let this to be my integral, now I'm going to multiply with an exponent, but with a negative xy, because if I bring in this idea, the exponent I'm multiplying with, it should be bringing me a 1. So that it doesn't bring in, because if we multiply it with x e power x, which is positive, it's going to bring ex squared here, which will bring more problems. So that's why I want to reduce this to 1. To reduce it to 1, I multiply with the same exponent, but with the x which is negative. So I multiply it up and down. So I multiply the side down with e of the opposite side of this up and also down. So it's that they will cancel. So now this multiplies this. I'll be having now my integral will be now e negative x dx over this times this. We are going to have this case. They are going to be multiplying, then this plus this. Is that they will add. You know, when they are multiplying numbers on the same basis, we add their powers. When you add negative x plus x, you get a 0. A number power 0 is 1. So that's why from here, I'm going to be adding this times this to get x. Now plus negative x, then minus this times this e negative x, which is going to simplify to e negative x dx over e power 0, then minus e power negative x. Because when we add those two, that's what we get. So my integral now is dx, the whole over. Now e power 0 is 1 minus e power negative x. Now you see that our main idea was to create a function and its derivative. You see that when we differentiate this, we get this. So we have created a function and its derivative. So this is our function, this is the derivative. What we do, we let the function to be any variable. So let's say, let u be now 1 minus e negative x. When we differentiate u, we get 1. When we are differentiating u equaling 2. When we differentiate 1, we get 0. When we differentiate the negative exponent over negative x, we get a negative. Now, this negative that we get is going to be now negative into. When we differentiate this, we get negative e negative x dx. So this negative and that negative is going to give us e now negative x dx. But so that the whole of this here is up here, and all of this is u. So now our integral is going to be integral e negative x dx is u. Then over the whole of this from here is u. So now our I is going to be natural log of u using this. This is a linear function. Natural log of u plus the constant of integration. But our I is natural log of u was given us as, okay, so I'm introducing the original function, which was our I. We see that my natural log is my integral I. My I was this, so my I dx 1 minus e x, sorry, it's e, sorry, so my integral, which is dx over ex minus 1 dx is natural log of u, but my u from here is 1 minus b negative x, then as c. Why? Because from here we know what our u is there. So as simple as that. So I think we can try out this. Now here I'm going to multiply through by and That's it, members. I wish you well.